Let's talk a little about assignment statements. Computer science is actually part of mathematics, and there's a deep relationship between computer science and mathematics. It's not at all unusual for computer scientists to have strong backgrounds in mathematics. For example, my college degree and my first master's degree are actually in math, not computer science. The notation is often very similar between computer science and mathematics, and that can be really helpful. The problem is that there are both subtle and profound differences in meaning for some mathematical symbols when they're used in programming, and that is a possible source of confusion. So let's talk a little bit about what the equal sign means in mathematics. When we say x equals sine 3, we mean x is 3. That is, the variable of x has a value of 3 forever and ever and ever. When we say x is 3 and x is 4, that's actually inconsistent, because once x has a value of 3 forever, it can't have a value of 4 forever. And so that's really a problem. The other thing is that 3 equals x and x equals 3 actually mean the same thing. Now there's a name for that property. It's called symmetry. And this is one of the critical properties of equality in mathematics. Now let's talk about the assignment statement in programming. The symbol is an equal sign, which is the same symbol that we use for equality in mathematics. The problem is that the assignment statement doesn't mean equality. When we say int x equals 3, we mean the location in memory that we've called x gets the value of 3. That is, that 3 is moved into that memory location. Right now. Not before, not after. This means that the location x may have a different value earlier or later. We really don't know. So there's a sense of timing in the assignment statement that equality doesn't have. Assignment statements in computer science are actions. Do this. Move this there. Whereas equality is a statement of properties, of being. Now let's talk a little bit about the asymmetry. When we say int x equals 3, we mean take the value on the right, that's the 3, and store it in the location on the left, that's the x. But it's asymmetric. Notice that in my description, right and left matter. I have to tell you which side to interpret which way. 3 equals x doesn't actually make any sense, because that would say take the value in location x and store it in location 3. Well, 3 isn't a legal name for a location. Remember that all of our variable names have to start with letters. They can't start with numbers. And so this just isn't sensible. It doesn't make sense. Confusing x equals 3 and 3 equals x is called assignment dyslexia, and it's something that beginning programmers sometimes have trouble with. So really think carefully about what it means and how right and left play into that. So 3 equals x doesn't make sense. X equals 3, you bet. Let's take an example of what asymmetry means to help you with this concept a little bit. Suppose I've declared an integer x and assigned the value of 10 and another integer y and assigned the value of 20. Are the two statements below the same? Is x equals y the same as y equals x? Well, to answer this question, I'm going to use something called a memory diagram. Very important tool for understanding programming. When we say int x equals 10, we create a location in memory. We show that as a box, and we label it x because that's what we're going to call it, and then we put the value 10 in that box. That's what int x equals 10 does. Int y equals 20 is the box on the right. So we create the location in memory called y, and we store the value 20 into it. Now, when we say x equals y, we mean they take the value in location y and store it in location x. Okay, pay attention to x because it's about to change. There it goes. Now it has 20 in it. Let's take a look at what happens when we say y equals x. The setup is the same before, but now we're going to take the location in x and store it in y. Pay attention to y. It's going to change. There it goes. So notice x equals y and y equals x mean different things. Now the values are equivalent in the mathematical sense after these operations are done, but the values are different. And that's what's critical. So left and right really matter here. Now the technique that I'm trying to show you here is called paraphrasing code. So for example, when we say int size in a program, what you should be thinking in your head, and what you may even want to say out loud, is set aside enough space in memory to store one int. Call that size. That's what int size means. And there's what it looks like as a memory diagram. When we say size is 3, we're saying take the value 3 and store it in location size. And right there is what that looks like. The value 3 goes into the memory diagram. Keep programming.